Defect leakage is a critical metric in software development that highlights the effectiveness of the testing and quality assurance processes. In essence, defect leakage occurs when a defect is introduced in one phase of development but is not identified until a later phase, often by the customer after the software has been released. This phenomenon reflects gaps in the testing process and can significantly affect product quality, customer satisfaction, and project costs. Understanding defect leakage is essential for any software team aiming to improve their development and testing practices. But the lifecycle of software development typically includes multiple phases: requirements gathering, design, coding, testing, and deployment. At each stage, defects may be introduced, whether due to miscommunication, coding errors, or design oversights. The purpose of each testing phase, unit testing, integration testing, system testing, and acceptance testing, is to catch defects early before they propagate to later stages. When defects slip through these phases unnoticed, they contribute to defect leakage. One of the main reasons for defect leakage is insufficient or ineffective testing. For instance, unit tests may fail to cover all possible scenarios, or integration testing may not fully validate interactions between modules. Inadequate test planning, time constraints, or reliance solely on manual testing can also increase the likelihood of defects escaping detection. Even when automated testing is in place, poor test coverage or incorrectly defined test cases can leave vulnerabilities undetected. Defect leakage is usually quantified as a percentage to provide a measurable indicator of testing effectiveness. The formula commonly used is defect leakage in percent equals defects found after release divided by the total defects found, both pre-release and post-release, multiplied by 100. A higher percentage indicates that a significant number of defects are being discovered after the product reaches the customer, signaling potential weaknesses in the testing and quality assurance process. Conversely, a low defect leakage rate suggests that most defects are being caught during development and internal testing phases. The consequences of high defect leakage are considerable. Defects discovered in production can damage a company's reputation, reduce customer trust, and incur significant costs in terms of bug fixes, support, and patch releases. Moreover, late-stage defect detection can disrupt project timelines and lead to delays in future development cycles. This makes defect leakage not only a quality concern, but also a financial and operational one. Defect leakage also serves as a feedback mechanism for improving software development processes. By analyzing the defects that escape testing, teams can identify patterns or weak points in their testing strategy. For example, recurring defects in a particular module may indicate gaps in code review practices or insufficient automated test coverage. Such insights enable teams to adjust testing focus, improve documentation, and enhance overall quality assurance measures. Several factors contribute to defect leakage, including complex requirements, frequent changes in specifications, and human errors during coding or testing. Miscommunication between development and testing teams can also lead to missed defects, as testers may not fully understand the intended functionality. Additionally, constraints like tight deadlines or limited resources can result in skipped or rushed testing, further increasing leakage. Preventing defect leakage requires a combination of proactive measures and continuous process improvement. Implementing thorough test planning, comprehensive test coverage, and early defect detection techniques such as code reviews, static analysis, and unit testing can significantly reduce leakage. Automated testing frameworks, continuous integration, and regression testing also play a crucial role in catching defects before they reach production. Collaboration between development and testing teams is another effective strategy to minimize defect leakage. Encouraging open communication, knowledge sharing, and involving testers early in the design and development phases can help uncover potential issues sooner. Additionally, prioritizing risk-based testing and focusing on high-impact modules ensures that critical defects are less likely to escape detection. In conclusion, defect leakage is a vital indicator of software quality and testing effectiveness. By understanding its causes, measuring it accurately, and implementing preventive strategies, development teams can reduce the number of defects that reach production. Minimizing defect leakage not only improves customer satisfaction and trust, but also lowers costs, enhances project timelines, and strengthens overall software reliability. Continuous attention to this metric ensures that software development processes remain robust, efficient, and capable of delivering high-quality products.